Hi girls, welcome back. We're going to start today and start this term by starting a little bit of organic chemistry. Okay, so we kind of started this just before we left, and I was kind of holding off on it to be honest, because ideally we would do this in class with you making models with the little atoms that we have in class. It's much easier that way and it's much more fun. But obviously, as time goes by, we have to keep going with the content. So I'm going to do my best to do it both with little clips like this and also with some slides in your folders. Okay, so it's not ideal. It's very dry, I suppose. A lot of this is terminology, but we have to keep plowing away, and I have to start some organic chemistry with you at some time. It's not difficult, I suppose. That's the only positive. It's not difficult. It's just like learning a new language, really. It's all about vocabulary. Okay, so I'm going to shut up and get on with it. What we're looking at today is organic chemistry, and organic chemistry is the study of carbon. All right. And I suppose this is all to do with the chemistry of carbon. There's millions and millions of carbon compounds. They're used everywhere all the time. And they're divided into, I suppose, into things called homologous series, which you can think of similar to families. Okay, so a homologous series, that's the word there, you can see it there. Oops, a bit wobbly, sorry about that. Homologous meaning the same, a series meaning obviously a group or whatever. You can think of that a bit like families. Okay, so there's different organic families and they have certain things in common. And one of the things that they have in common is they have the same functional group. And the functional group is the part of a molecule which makes it belong to that series. Okay, now I'm kind of throwing words at you here that I think will become more clear as we do examples. Okay, so that's kind of the easiest way to do this, is by examples. So we're going to start today by looking at one of the families, one of the homologous series, and the first one, and they're called alkanes. And alkanes are a type of organic chemical called hydrocarbons. And the clue there is in the name. They're made of only hydrogen and carbon. There are no other atoms present, only hydrogen and carbon. And alkanes have only got single bonds between the carbons. That's all they have. They've only got single bonds. There's no double bonds. There's no oxygens. There's no nitrogens. There's no nothing else. Single bonds between carbons and hydrogen atoms. And you already know one of these. The first one that you should know is this one here, CH4, which is methane, which you would have drawn for your junior cert. So if you can, I want you to pause the video here now and see if you can draw a methane molecule for yourself using your periodic table to help you if needs be. Okay, so hopefully what you drew looks something like this. You drew a carbon atom like this, with 6 protons, 6 neutrons. Each of these is a hydrogen atom, and each of them has a covalent bond. They're sharing a pair of electrons like this. All right, now that's quite a messy diagram, as you can see. When we're talking about organic chemistry, really we're not interested in all the protons and neutrons and all the electrons. We're really only interested in the electrons that are involved in the bonding. So oftentimes we'll draw it like this. We just have a C there for carbon, and now what I've done is I've drawn just the electrons involved in the bonding. So that's a little bit simpler. And sometimes we even do it like this one, see? Where I've gotten rid of the circles and we've done what's called a dot and cross diagram. You've drawn them earlier in the year already. Okay, you can see that there's each point here between the atoms, there's a pair of electrons. The X's and O's are just to represent different electrons from different atoms, okay? But they're essentially the same thing, aren't they? A pair of electrons. And sometimes we draw it just like this, where we have a line between the two atoms showing a bond, a pair of electrons like that. So this is a methane molecule, okay? All of these diagrams are correct. They're just different ways of showing the same thing. Largely, we're going to be using this type of drawing where we show what each of the atoms bonded like that. Is that okay? So methane is this. There it is. That's methane. And that's the first member of the family, the first member of the alkanes. But there are other members, because what we can do is, after methane, we can add carbons in our chain. So we can put 2 carbons in our chain, and we call that ethane. We can put 3 carbons in our chain, and we call that propane. We can put 4 carbons in our chain, and we call that butane. Now, the names here are really important. You'll notice that each of them ends in ANE. All the alkanes end in ANE, a bit like we said, the alkane is a bit like a family, a bit like, in this part of the world, our families have the same surname, don't they? So they all have the same ending. The first part tells us how many carbons are present. So later you'll see when we look at other families, they also use this naming system. The first one is meth, the second one is eth, the third one is pro, and the fourth one is bute. Is that okay? Good idea maybe to have a little kind of clever mnemonic to help you remember this. A good one is monkeys eat peeled bananas, but you can make up your own one if you prefer. What's important to know is that this can go on and on, even longer than this. We can have 5 carbons, 6 carbons, 7 carbons, but the names are a little bit easier to remember after this because they follow the shapes in maths. So for example, an alkane with 5 carbons is called pentane, as in pentagon. One with 6 carbons is called hexane. 7 carbons is called heptane. 8 is octane. You get the idea, right? So it's only really the first 4 that are a little bit confusing. Is that okay? So that's what I wanted to do today, was just to introduce you to alkanes and to get you used to drawing them and drawing the naming system associated with them. That's all I wanted to do today to get us started. Okay, thank you. Bye-bye.